So let's look at a problem that's a little more difficult and something that most people won't be able to just glance at and understand what's happening without thinking about it. So in this example, a car is initially moving to the right at a speed of 10 meters per second. It increases speed smoothly for 6 seconds, ending with a speed of 40 meters per second. How far does the car travel in that time? So this isn't like the last one. We could just say, okay, well, it was traveling at 40. It did that for 6 seconds, kind of like, if you're driving your car and you can travel at 60 miles an hour, and you do that for 2 hours, you say, well, it went 60 plus another 60 is 120. You can't do that with this problem. So we have to be a little smarter. So let's use the process that we went through last time. It says, draw the car at the start. This is time t equals 0. It's starting at position 0. And what's its velocity at the start? Well, the car is initially moving at v equals 10. So that's the starting speed of the car. And then we say that it increases its speed smoothly for 6 seconds. Well, I could draw a motion diagram right now because when I see that something's got increasing speed, I know what that looks like. So that's going to look something like this, where the velocity vectors are going to be getting longer and longer to the right. And I know if I have straight line motion with increasing speed, that my acceleration is going to point that way as well. In this particular problem, there is an acceleration, and we'll calculate that at the end. So this is just to help me understand what's happening. So now I get to the final position, and I have to put down the time, the position, and the velocity again. Well, at the end of this problem, increases its speed for 6 seconds. So the time is 6 seconds. And we're told that the ending speed is 40, so I'm going to put that down there as well. But I also need to try and find out what the position is. Well, that's what we're trying to find. How far is the distance? So I don't know that one, but I do know that the final velocity is 40 meters per second. Now, if I just stop and think about this problem, again, I'm trying to find the displacement or the x2. That's what I'm looking for in this problem. If I think and compare this to the previous one, the previous problem, the car had a constant speed of 40 the whole time. So it was kind of moving like this for the 6 seconds. In this case, it starts out slower and finally gets up to that same speed that the other one finished at. So there wouldn't be any way that I could imagine this car could have traveled as far as the previous car did. So that's what I'm going to keep in mind when I do the calculation to make sure that everything's making sense. All right, so I'm trying to find the displacement. There's only one formula that we have that involves displacement. All right, so we pulled this one out, and we know that the displacement, delta x, is the average velocity times the time. Well, in this one, I don't know the average velocity off the top of my head, so I have to think about, what do I know about average velocity? It's always 1/2 v1 plus v2. And again, I don't ever want to read this problem again. You probably don't either. But the picture should have everything. If you cannot find something you need in the calculation from your picture, that means you haven't drawn a good picture. Right? So you've got to think about that. So in this case, my starting speed, I'll look at the picture. There it is. And the final speed, look at my picture, there it is. So 10 plus 40 is 50. 1/2 of 50 is 25. So I know the average velocity is 25 meters per second. This is a really important point for you to stop, take a breath, and think about it. This speed is supposed to be the average. If I start at 10 and I end at 40, I need to find a speed that's somewhere in the middle. Well, this 25, it's actually 15 bigger than the starting speed, and it's 15 smaller than the final speed, so we did it right. But it's really easy to make simple mistakes. Sometimes people divide by the time, the 6 seconds. If you'd taken 50 and divided by 6, instead of dividing by 2, right? Again, you shouldn't divide by 6, but if you did, just because you made a mistake, 50 divided by 6, it's around 8. There's no way the average speed could have been about 8 meters per second when the slowest speed was 10. So that would immediately tell you that you've made some mistake along the way. Similarly, sometimes people subtract the speeds. So if I'd done 40 minus 10, let's say, for some reason, and then divided by 2, I would have ended up with 15 as an answer. Well, if I start at 10, and I say that 15 is the average, but the final speed was 40, that's way too far away as far as a number goes. So you've really got to think when you do any calculation, does it make sense? So I'm going to take my 25 for the average velocity and plug it back into this equation. The time was 6 seconds. That was in the problem. And so I just multiply the numbers. 25 times 6 is 150. And the distance, since it's a distance, it must be in meters. And so I find that the distance that the car traveled was 150 meters. And I slow down and I think for a minute. And I say, well, you know what? That's less than happened last time when the car traveled at 40 meters per second for the whole time. It went 240 meters. This is less than that. That makes sense. If the car traveled at 10 meters per second for the whole time, so at a really slow speed, 10 meters per second, for 6 seconds would only have been about 60 meters. So this should be more than that, and it is. Right? So it seems like it's a reasonable number, and we should be pretty happy with that. All right, just quickly, let's think about what the acceleration is. I'm going to move this board out of the way. So if I want to find the acceleration, I only have one equation that I could use. Right, it's that the change in velocity divided by the time is equal to the acceleration. So if I still have my picture here, I'd look back to the picture and say, what was my V2? Well, I can remember. V2 was 40 meters per second. V1, the starting speed, in this problem, the starting speed was 10. And the total time that it took? 6 seconds. Again, I've left the units here just one time. The answer for acceleration is always going to be meters per second, or meters per second squared. But I want to use it this time just to show you how that comes about. So we'll do the calculation on the top. Right, 40 minus 10 equals 30 meters per second on top, divided by 6 seconds. Now our old trick says, just do the numbers first. So 30 divided by 6 is 5. And we have meters per second on the top. And on the bottom, we still have seconds. Right, so it's meters per seconds per second. Sometimes people think that the seconds are canceling out, and I understand why you might think that. But remember, if you're dividing by something, this is really the same as saying 5 meters per second divided by seconds. But if you divide by something, that's the same as saying multiplying by 1 over it. So we have meters on the top and we have seconds and seconds on the bottom. So this is really 5 meters per second squared. It's certainly one way to write this answer out for the acceleration. I actually prefer going back to this stage. So I'm going to rewrite this. And in words, what this means, and this is why I like to do it, it's saying the acceleration is 5 meters per second per second. So every single second, the change in the velocity of the car was 5 meters per second. And since it's a positive number, that means that it's going faster by 5 meters per second every single second. And if we go back to think about this, right? So we started at 10. What the acceleration tells us is that 1 second later, it's traveling at 15. 1 second later, it's traveling at 20, then 25, then 30, then 35, then 40. So the acceleration, and usually what I'm going to write out my answers, I'm going to say how many meters per second it is per second for the acceleration. It reminds you that the acceleration is telling you how the velocity changes every single second. And so that's our answer. Or again, you could say meters per second squared, but I think I kind of lose track of what it means when I write as meters per second squared, what it physically really means is that every single second, the speed changes or increases by 5 meters per second. Great, and that's the end of that problem.